Hey there, maths guys. Guide is maths. We've got this absolutely absurd line and circle question that we're going to have a go at here. 10 marks. See what's going on over here. So we've got our line L. We have an equation y equals mx plus 8. Got our circle C, normal sort of stuff. We've been told m is greater than 0 and that L is a tangent to C. We might already be thinking about what we're going to do with that. Find the coordinates of the point where L and C meet. Right, so you guys know at this point, if we're looking for anything to do with where lines, curves, two things meet, simultaneous equations, you know the deal. So we're going to try and solve these simultaneously and see where it gets us. We'll deal with it when we get there. Okay, so we're going to put y equals mx plus 8 into this one. So because it's already in the form y equals, we'll replace this y squared and this y here and see what we've got. So we've got x squared plus mx plus 8 squared minus 8x plus 3 mx plus 8 minus 20, and we'll just jump over our line here. Need a bit of space for this one. Equal to 0. Right, so there we go. We've subbed in our line equation to our circle equation. Now we've just got to expand it. So we've got x squared plus m squared x squared. When we expand this one, remember it is a double bracket. We'll get 16mx, remember 8mx twice. So we get 16mx plus 64 minus 8x plus 3mx. I was ambitious with this line divide, wasn't I? Plus 3mx plus 24 minus 20 equal to 0. So now we're going to tidy up the like terms. So we'll have a little scan through. So we've got our x squared plus m squared x. Can't do anything with that really at the moment. We've got this 16mx and this 3mx. So we can do a 19mx. Make that a little bit nicer. We've got our minus 8x. There are no other x terms with just a number, so we're going to have to stick that in as it is. And then we've got our 64 and our 24 and our 20, which is going to get us a plus 68 equals 0. And then we'll put our x squared plus m squared x squared over at the start. Now we might already be remembering the sort of thing we're dealing with here. So we have a quadratic equation that will tell us the points of intersection between our line and circle. We've been told that we want the line to be a tangent to the circle, which means it will only meet at one point, which means this needs to only have one solution. So we're going to have a look at our discriminant, aren't we? So let's write it a little bit nicer for us for our discriminant purposes. So we can take the x squared out of this and make it 1 plus m squared. So we can now see what our a is for our discriminant. We've got plus 19m minus 8. X, that's our b for our discriminant, and then plus 68 tagged on the end, equal to 0. All right, so there's our quadratic in about as nice a form as we can write it. Now we've got to do our discriminant, okay? So we've got b squared, so 19m minus 8, let's square that, minus 4 times a, which is this 1 plus m squared we've got over here, times c, which is 68. Wow, this is fun. So at this point, we make a decision. So we know we want it to be a tangent. We've already said we want that quadratic that we've got here to then only have one solution. So if we're looking at a discriminant and we only want one solution, it's got to equal 0. Remember, if it was greater than 0, it would have two distinct solutions. Less than 0, no solutions. In the middle, we've got our one solution, which means we want it to equal 0. So need to expand this one now, right? So this is getting pretty horrible. So we've got 19m times 19m, so that'll get us 361m squared. It's already off to a good start. Then we've got minus 8 times 19. So what's that going to be? Minus 80, minus 152, double that, minus 304m. Plus 64. It's going well so far. Then we've got minus 4 times 1 plus m squared times 68. So the 4 times 68, if we do that, 4 times it would be what, 240. And then we're going to add on 4 times 2, which is 32. So 272 is 68 times 4. I'm going to times that by 1, so minus 272. And then by m squared as well, minus 272 m squared. Right, equals 0. Don't forget the 0, that's what we're here for. So we're going to try and tidy that one up a little bit. So we've got 361 m squared minus 272 m squared. So if we carefully work that one out, what's that going to be? 89m squared. So we've got 89m squared. Done that one. Who wrote this? Minus 304m is the only m one we've got. There we go. We can park that one in there. It's a bit nicer. And then we've got plus 64 and minus 272. That's almost within the realms of doable maths. So we get minus 208 equal to 0. I mean, the line divider's just gone by this point, right? I was being optimistic about splitting my board up. So here's our quadratic for m that we now need to try and solve. Now, obviously, at A level, we'll just stick it in a calculator, right? Let's be honest. We're just going to stick it in a calculator. So we'll go on to our quadratic solving functionality on our calculator and stick this one in. You could do quadratic formula. I mean, you know, it's up to you how long you want to do that. So what have we got? 89 minus 304 minus 208, which get, oh, who would have thought that, looking at that quadratic? So we get m equals 4, nice, or minus 52 over 89. Now I know which one I'm hoping we're going to use. Oh yeah, m was greater than 0. We're okay. So we can use our m equals 4 and ignore this one because it's less than 0. So we're not going to use that one for our values. All right, there we go. So we now know the value of m. So that means now we can try and carry on with the rest of it. Remember, that wasn't the aim. The aim is to find out where the coordinates are. So if m equals 4, we now know this line is y equals 4x plus 8. So some people are sometimes tempted to go back to the beginning and start with y equals 4x plus 8 and repeat. Don't want to do that. Now remember, what we did, we've already done the simultaneous equations, and we got down to this one here in terms of m, right? So this equation here, that's the one we found would give our solutions for where the line and the circle intersect, and it's in terms of m. So we just substitute our m equals 4 into that equation, and then we have the equation we need to solve to find out our point of intersection. Much easier, right? So if we go through, we've got 1 plus m squared. So m is 4. Remember, makes life a bit easier. That's our x squared coefficient, so we put our x squared in. Plus 19 times 4 minus 8. That's our x. And then we've got plus 68 equals 0. Plus 68 equals 0. All right. So we'll simplify that, see what we get. So we've got 4 squared plus 1, obviously gets us 17x squared. 19 times 4 gets us 76, minus 8 gets us 68. So we're going to have plus 68x, and then plus another 68 here. Now again, it might look horrible, but if we're good at arithmetic, we might spot 68 is a multiple of 17. Nice result. So we divide the whole thing by 17. We get x squared plus 4x plus 4 equal to 0. Don't need a calculator for this one. So this one's going to factorize. We've got x plus 2, x plus 2, which means we get one solution. Now remember, we were only expecting one solution. Glad that's worked out all right, because we knew it was going to be a tangent. So if I had two different values for x where the line and the circle met, we'd have just hit a massive brick wall. So I think we're good, because we've got one answer. So we know x is minus 2. And then, as always, simultaneous equations, we need to go back and find out what y is. So you've got your choice. You can do the line or the circle. I know which one I'm picking. So remember, we know the equation now is y equals 4x plus 8, because we found out that m was 4. So y equals 4x plus 8. And we'll sub our value for x equals minus 2 into that. So we've got y equals 4 times minus 2 plus 8, which actually turns out to be 0. So 4, 0 is the coordinates of where our line and circle meet. There we go. Got a bit messy in the middle there. Turned out nice in the end. So let me know how you got on. I'll tell you what, here's your challenge for you. Let me know in the comments if you can find out where the other point of intersection would be if we used minus 52 over 89 as our value for m. Have a go at that one if you want a challenge, and let me know how you get on in the comments. Okay, so like and subscribe for more maths content from me. Awesome job as always. See you next time.